Next, 10th. When the two resistors are connected in series and parallel combinations, their equivalent resistance are 15 ohm and 56 by 15 ohm. Find the individual resistance. Find the individual resistance. Okay, they are given the series combination resistance R1 plus R2 is equal to 15 ohm. Rp is equal to, we know, R1 R2 by R1 plus R2 is equal to 56 by 15 ohm. 56 by 15 ohm. Okay. Now we can substitute instead of R1 plus R2, we can substitute 15. அப்போ RP is equal to எனக்கு என்ன தெரியும் 56 by 15 is equal to R1 R2 by 15. So from this R1 R2 is equal to 56 by 15 into 15. 15 gets cancelled, so 56. From this I can find R2 is equal to 56 by R1. 56 by R1. Now substitute into the series equivalent. Okay. 15 is equal to, instead of R1 keep it as such, instead of R2 I can substitute 56 by R1. 56 by R1. When you simplify, we get, take LCM and simplify, we get R1 squared minus 15 R1 plus 56 equal to 0. When solving the factorization, using this factorization, I can write R1 squared minus 8 R1 minus 7 R1 plus 56 equal to 0. Plus 56 equal to 0. Okay. Now take as a common as a R1. R1 minus 8. Here 7 as a common. So R1 minus 8 equal to 0. Now we get R1 is equal to 7 and R1 is equal to 8. And R1 is equal to 8 ohm. Okay. Take the first one. Take the first one. Series la. 15 is equal to, instead of R1 I can substitute 7. 7 plus R2. We get R2 is equal to 8 ohm. R2 is equal to 8 ohm. If we substitute R1 as a 8, R1 is the 8. 15 is equal to 8 plus R2. 8 plus R2. R2 is equal to 7 ohm. R2 is equal to 7 ohm. Okay. So now we get the individual resistance 7 ohm and 8 ohm. Another combination 8 ohm and 7 ohm. 8 ohm and 7 ohm. There is a individual resistance. Next one, calculate the equivalent resistance between the A and B in the given circuit. In the given circuit. This is a part 1, part 2, part 3. Here they are connected in parallel. Here parallel, here parallel. In the first part, parallel combination 1 by Rp is equal to 1 by 2 plus 1 by 2 is equal to 2. Okay, 2 by 2 is equal to 1. 2 by 2 is equal to 1. So simply Rp is equal to 1 ohm in the first part. In the second part, here also 1 by Rp is equal to 1 by 4. 1 by 4 plus 1 by 4, we get 2 by 4. 1 by 2. Simply Rp is equal to 2 ohm. Okay. In the third part, the same one, 1 by Rp is equal to 1 by 6. 1 by 6 is equal to 2 by 6 is equal to 1 by 3. So simply Rp is equal to 3. Simply Rp is equal to 3. Now circuit will become like that. All the one are series combination 1 ohm, 2 ohm, 3 ohm. But in this series combination, the total resistance Rs is equal to 1 ohm plus 2 ohm plus 3 ohm is equal to 6 ohm. That is the equivalent resistance for this combination. For this combination. Okay. In the next one, the 5 resistors are connected in the configuration as shown in the figure. Calculate the equivalent resistance between the point A and B. Point A and B. Okay. 5 resistors are connected in this network. So in this case, we assume the current is entering into the junction A. All the resistors are in the outside loop having the equal value as the 1 ohm. So current in the branches AC and AD will be equal. So potential at the point C and D will be same. Because of this, there is no current flowing through the 5 ohm resistor. So in this calculation, the 5 ohm resistor is not included. Not included. So now circuit will be simplified as like that. Circuit will be okay like that. 1 ohm, 1 ohm, 1 ohm, 1 ohm. These two are parallel, here are parallel. 1 by Rp is equal to 1 by 1 plus 1 by 1. So 1 plus 1, 2. 1 plus 1, here 1 plus 1, 2. Simply Rp is equal to 1 by 2. In the same one, another combination. Here also we get a 1 by 2. Circuit will become like that. Here 1 by 2. For this combination we get a 1 by 2. Series combination Rs is equal to here R1 plus R2. 1 by 2 plus 1 by 2 we get a 1. So simply Rs is equal to 1. So equivalent resistance is 1 ohm. Equivalent resistance is 1 ohm. Next, if the resistance of the coil is 3 ohm at 20 degrees Celsius and alpha is equal to 0.004 degrees Celsius, then determine its the resistance at 100 degrees Celsius. They are given the R naught, that means at 0 degrees Celsius, R is equal to 3 ohm, alpha is equal to 0.004 per degree Celsius. They are asking the RT, so R naught is 3, 1 plus alpha is equal to 0.004 into change in temperature as the, 20 degrees Celsius and 100 degrees Celsius. 100 minus 20 we get a 80. We get a 80. What is the value? 3 into 1 plus, if you multiply, we get a 0.32. 3 into 1.32, we get a 3.96 ohm. 3.96 ohm. Okay. That is the RT at 100 degree Celsius. Next, resistance of the material at 10 degree Celsius and 40 degree Celsius is 45 ohm and 85 ohm. Find the temperature coefficient of the resistance. They are given the T naught 10 degree Celsius, next 40 degree Celsius. So R naught is the 45 ohm and RT is the 85 ohm. 85 ohm. We know the formula. Alpha is equal to 1 by R naught into del R by del T. So 1 by R naught value is the 45. Change in resistance 85 minus 45 divided by 40 minus 10. We get 1 by 45 into 40 by 30. 40 by 30. If we simplify, we get alpha is equal to 0.0296 per degree Celsius. Per degree Celsius. Next, a battery of the voltage V is